Everyone knows the story of Apollo 13 astronauts. They only know half the story. The public remembers Jim Lovell, Jack Swigert, and Fred Hayes adrift in space, facing impassable odds. The crisis aboard Apollo 13, a mission crippled 200,000 miles from Earth, is a legend of human endurance. But that endurance was forged not just in the cold vacuum of space, but in the sweltering, smoke-filled rooms of mission control. Beneath the glare of fluorescent lights, a different kind of hero was at work. They were the ground crew, an army of engineers, technicians, and specialists. Their names rarely make the headlines, but without their relentless ingenuity, the crew of Apollo 13 would never have made it home. The clock was ticking from the moment the infamous bang reverberated through the spacecraft. An oxygen tank had exploded. Power was failing. Carbon dioxide levels were rising. It was a cascade of catastrophic failures, each demanding an immediate, unprecedented solution. The first critical challenge: power. The command module Odyssey was dying. The lunar module, Aquarius, designed for a 2-day lunar stay, now had to become a lifeboat for 3 men for 4 days. It wasn't built for that. Every watt counted. Led by Flight Director Gene Kranz, a man whose resolve was as unyielding as his white vest, the teams in mission control began an impossible task: to power down the lunar module to unprecedented levels, conserving every last electron. They had to invent new procedures on the fly. One of the unsung architects of this power miracle was John Aaron, a young electrical engineer. He'd been involved in previous crises, known for his calm under pressure. Now, he was instrumental in devising a power-down sequence that would later be described as a miracle. Then came the carbon dioxide. Aquarius's life support system was designed for 2 men. With 3, CO2 levels quickly became lethal. The square CO2 filters from the command module wouldn't fit the round receptacles in the lunar module. A deadly engineering puzzle. This is where the MacGyver moment happened. Engineers, led by Ed Smiley, were given a box of random items available on the spacecraft: cardboard, plastic bags, duct tape, and a sock. Their mission: build a filter adapter using only those materials. Back on Earth, a team frantically worked in a simulator, replicating the conditions. They built a crude, yet effective, adapter. Their instructions were then relayed, step by step, to the astronauts hundreds of thousands of miles away. It was a triumph of improvisation. The astronauts, guided by the ground team, built the mailbox filter adapter. It worked. Carbon dioxide levels began to drop. Another hurdle cleared, another testament to the collaborative genius of those on the ground. The next challenge: navigation. With the command module dead, the primary guidance system was useless. The astronauts needed to burn the lunar module's engine to correct their course for Earth. But how do you aim a dead ship? The solution came from engineers like John Llewellyn and his team. They used the Earth's terminator line, the boundary between day and night, as a reference point. A seemingly simple idea, but revolutionary in its application. The astronauts aligned their spacecraft by sighting the terminator through the lunar module's windows, a feat of precision guided by complex calculations from Earth. It was a celestial equivalent of shooting a needle in a haystack from orbit. Then came the issue of re-entry. The command module, chilled to near-freezing temperatures for days, had to be powered up again. No one knew if the delicate electronics would survive the extreme cold and the subsequent thermal shock. Again, John Aaron was central. He'd been through a similar cold start procedure during the Apollo 1 fire investigation. His experience and meticulous planning were vital in crafting the reactivation sequence, a sequence that had never been tested under such conditions. The command module, Odyssey, slowly hummed back to life, piece by agonizing piece. Each circuit breaker, each switch, had to be thrown in a precise order, carefully timed to minimize power surges and system shock. The final harrowing moments: atmospheric re-entry. The communication blackout, always a tense period, was longer than expected. Had the heat shield failed? Had the cold destroyed critical systems? Then a flicker of light, a faint voice. The parachutes deployed. The command module splashed down safely in the Pacific, Cheers erupted in mission control. Relief washed over the faces that had been etched with worry for days. The ground crew, working round the clock, fueled by coffee and sheer determination, had performed miracles. They improvised, innovated, and collaborated under unimaginable pressure. Their teamwork was the unseen force that pulled Apollo 13 back from the brink. From the go/no-go decisions to the meticulous calculations to the makeshift solutions, every crisis was met with a surge of collective human brilliance. It wasn't just individual heroism. It was a symphony of countless minds working as one. The story of Apollo 13 is a testament to the astronauts' courage, yes, but it is equally, if not more so, a testament to the unsung heroes on the ground. The people who made the impossible possible, not with grand gestures, but with relentless problem-solving and unwavering dedication. They were the true architects of Apollo 13's survival, a reminder that behind every dazzling space triumph, there's an unseen legion of brilliant minds ensuring success, or in this case, simply survival. Discover more about the unsung heroes of space exploration in our next deep dive.